There are many types of mysterious and perplexing objects within the universe, but there are three main objects that are the most interesting, and these phenomena are black holes, quasars, blazars, and pulsars. Yet many features about these objects are still unknown. I am here to educate you on the known facts of these phenomena. Black holes. A black hole is a large region of space-time where there is enough gravity that is so strong it deforms into an impossible form of space. It is where nothing, no particles, or even electromagnetic radiation, such as light, can escape the infinite density. The boundary of a black hole is the region where nothing can escape, the event horizon. Even though the event horizon has a huge effect on the fate of an object crossing, there are no visible detectable features. Types of black holes. There are four types of black holes, each different yet similar. Stellar mass black holes are the most well-known black hole. It is caused by the star reaching the end of its life and implodes, collapsing in on itself. If the star has a mass between 8 to 20 times the mass of our Sun, it will instead cause the star to erupt into a violent supernova. But if the star has a mass of over 20 times the mass of our Sun, it will then become a black hole. Intermediate mass black hole, as the name implies, is between the mass of a stellar mass black hole and a supermassive black hole. It is not too big and it is not too small, but it is rare. It is thought to form when multiple stellar mass black holes undergo a series of merges with one another. These merges often happen in crowded areas of galaxies. The black hole eventually zip around each other, faster, quicker, until they form a larger black hole. Supermassive black holes are formed when, mentioned before, it grows larger and larger through mergers. As it merges with one another, it sometimes gets so massive it sinks to the center of its galaxy. It gobbles up other material and other black holes while on its way to the center, and while it is there, it continues to eat. After billions of years, these black holes tend to have the mass of a million times the mass of our Sun. Primordial black holes are theoretically formed just mere seconds after the creation of the universe, the Big Bang. After the Big Bang, the young universe was filled with charged atoms. These insanely energetic particles directly collapse in on itself to create a primordial black hole. Depending on how soon the Big Bang happened, these black holes could have had a mass ranging from 0.00001 times the mass of a paperclip to the mass of 100,000 times the mass of our Sun. In addition, the very center of a black hole contains a singularity. It is a region where space-time curvature becomes infinite. In actualization, anything can technically become a black hole if it is compact enough. You can be a black hole only if you're the size of an atom. If the Earth was shrunk to the size of a peanut, you will have a black hole. A quasar is the event in which a black hole completely shreds a nearby star, becoming the brightest objects within the universe. As the black hole shreds the Sun, the black hole creates an accretion disk, formed by matter from the Sun and other photons. It quickly surrounds the black hole and inevitably enters the black hole's infinite density, or the matter gets shot out of the black hole's magnetic axes. These shots are called relativistic beaming. These beams can be shot out to near speeds of light. The distance shot out is equal to the distance from the Sun to Pluto and back 1.5 million times. 1,770 quadrillion kilometers into space. Blazars are essentially quasars, but if the stream, a cloud of matter created from the accretion disk forming outside the accretion disk, is angled slightly away from us, it is a quasar. But if the stream is angled exactly at us, it is a blazar. Pulsars and neutron stars. Neutron stars are objects with very small radius, roughly 30 kilometers, and a very high density, composed mostly of closely packed neutrons. Neutron stars are thought to form by the gravitational collapse of a massive star after a supernova explosion, provided that this star is insufficiently massive to produce a black hole. Pulsars produce a pulse of radiation ranging from milliseconds to seconds. The pulses detected are jets that produce a strong beam of light that funnel out the strong magnetic poles of the neutron star. The neutron star has a magnetic pole that is spun on with another axis that shoots out the beam of light. Two separate axes onto the one pulsar. The only way to detect a pulsar is if the beam of light is rotated exactly where Earth is, much like how the only way to see the light from a lighthouse is if the light shines towards the object. Not all neutron stars are pulsars, but all pulsars are neutron stars. There still are numerous other objects that I can educate you about, but black holes are mysterious. Quasars are dangerous yet beautiful, and the pulsars' shine catches your curiosity without any further questions. Thanks for watching.